Hello everyone, welcome to L Mathematics channel. Today we are going to solve one of the famous trigonometric identity as shown here. Here we have to prove 2 sin x divided by 1 plus cos x plus sin x equal to 1 minus cos x plus sin x divided by 1 plus sin x. To solve this problem, we have to check what has happened to the left hand side in order to derive right hand side or vice versa. By looking at the both sides, we can see that the denominator of the left hand side is the conjugate of the numerator of the right hand side. But we can only understand it by simply rearranging the left hand side as follows. So let's rearrange it, and then we can multiply both top and bottom of the left hand side by the conjugate of the denominator in the left hand side. Then it will deliver numerator of the right hand side, and we have to calculate the rest. By comparing at right hand side, we can see that 2 sin x, which is at the left, is not in the numerator of the right hand side. So during the calculation process, it should cancel out. So I am not calculating the numerator of the left hand side and calculate only the denominator. So we can see it is the difference of two squares, and I will further expand the perfect square also. By comparing the denominator of the right hand side, we should understand that 1 plus sin x factor should come out. By expanding the perfect square, I can rearrange 1 minus cos squared x as sin squared x, because there are no cos x terms in the denominator of the right hand side. So I can derive left hand side denominator as 2 sin x plus 2 sin squared x. Now we are almost done. We can get the factor out, which is 2 sin x and 1 plus sin x, and 2 sin x will cancel out, and we get the right hand side. So the tricky part in this problem is to identify that conjugate of the denominator of the left hand side is in the numerator of the right hand side. At the first look, it is quite hard to identify, but with some small rearranging, the problem can be easily solved. So if you like, please thumbs up and subscribe for more cool videos.